NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new.
When you really think about someone saying, let's invent a telescope that can see,
I don't think it is very useful to speculate on what God might or might not be able to do.
When the James Webb Telescope focused on Proxima B, it uncovered something that made scientists freeze in fear. This planet, sitting in the habitable zone of its star, should have been a beacon of hope for life beyond Earth. Instead, what they found suggests Proxima B could be hiding something terrifying, something we're not prepared to face. Could this discovery change everything we think we know about life in the universe? Let us uncover what they found and why it made the government fire everyone involved in the discovery. Strange signals from a distant super-Earth. For centuries, humans have speculated about the existence of life beyond Earth. Books, movies, and theories have captured our imagination, driven by an innate need to find companionship in the vast emptiness of space. This curiosity has propelled monumental achievements in space exploration. And now, with tools like the James Webb Telescope, we're finally peering into the farthest corners of the galaxy. Proxima B, with its unique characteristics, has become a focal point in this quest. However, what the telescope uncovered has shifted the narrative from hopeful discovery to unsettling revelation. Before we dive deeper, it's clear that what was uncovered on Proxima B is far more unsettling than anyone anticipated. And this is only the beginning of the terrifying truth. Proxima B orbits its host star, Proxima Centauri, in a manner that initially appeared promising for supporting life. Locked in a tight orbit, one side of the planet permanently faces its star, while the other remains shrouded in darkness. This tidal locking creates extreme environmental conditions. The day side bakes under relentless radiation, while the night side freezes in perpetual shadow. Yet scientists speculated that an advanced civilization, if present, might have adapted to such conditions. They theorized that solar panels could harness the star's energy on the day side, distributing power to sustain life in the planet's colder regions. The James Webb Telescope's mission was to investigate these possibilities, and it did so with startling results. The telescope's instruments detected faint but distinct light patterns emanating from the dark side of Proxima B, initially thought to be natural reflections. Further analysis suggested these lights were structured and consistent, resembling artificial illumination. Such a finding implied the presence of advanced technology, possibly even an intelligent species, on the planet. This revelation sent shockwaves through the scientific community. Was humanity on the verge of confirming extraterrestrial life? Or was there a more sinister explanation lurking behind these artificial lights? To understand the significance of these findings, let's delve deeper into Proxima B's environment. The planet is classified as a super-Earth, slightly larger than our planet, but lighter than the gas giants like Neptune and Uranus. It exists within Proxima Centauri's habitable zone, where conditions could theoretically allow for liquid water. However, its proximity to its star also exposes it to intense radiation, raising questions about its ability to support life as we know it. Despite these challenges, the light emissions detected by the James Webb Telescope suggest the possibility of technological solutions to overcome these hurdles. Adding to the intrigue, the telescope identified peculiar atmospheric compositions on Proxima B. Traces of gases like methane and carbon dioxide appeared in unnatural ratios, further hinting at potential industrial activity. Such imbalances are often considered biomarkers, indicators of life processes or advanced technologies. If these atmospheric signatures are indeed products of intelligent design, then the implications are profound. Humanity might not just be looking at a distant cousin in the cosmos. We could be staring at a mirror reflecting our future possibilities or perils. The history of exoplanet discoveries has always been a roller coaster of hope and skepticism. The first confirmed detection of an exoplanet occurred in the early 1990s, and since then, thousands more have been cataloged. Yet none have captured our collective imagination, quite like Proxima B. Its proximity to Earth and its position within the habitable zone make it a prime candidate for exploration. However, these recent findings suggest that Proxima B might be more than just a target for scientific curiosity. It could be a warning. Consider the possibility of an advanced civilization on Proxima B. If they exist, their adaptation to such extreme conditions would likely require technologies far beyond our current capabilities. Solar energy harnessing, climate regulation, and artificial illumination are just the beginning. However, the presence of these technologies also raises concerns. Are these beings peaceful explorers of their harsh environment, or do they harbor intentions that could pose a threat to other civilizations? The James Webb Telescope's data offers no definitive answers, only more questions. What we found on Proxima B didn't just show new ideas, it brought worries we might not be ready for. Why Proxima B refuses to answer back? What's even more alarming is the potential for communication, or the lack thereof. Attempts to identify radio signals from Proxima B have yielded inconclusive results. A narrowband signal detected in recent years sparked excitement but was later dismissed as likely terrestrial interference. The absence of clear communication could suggest that any intelligent life on Proxima B is either unwilling or unable to engage with us. Alternatively, it might mean that they are actively avoiding detection. Both scenarios are unsettling, to say the least. The role of the James Webb Telescope in this investigation cannot be overstated. Its ability to capture infrared light allows it to peer through cosmic dust and uncover details invisible to previous instruments. By analyzing the light spectra from Proxima B, scientists can infer the composition of its atmosphere, the presence of potential water sources, and even surface conditions. These capabilities make it a cornerstone in humanity's search for extraterrestrial life. However, as with all great tools, the telescope's findings are only as useful as our interpretations of them. And interpreting these latest discoveries requires caution, curiosity, and a readiness to confront uncomfortable truths. One particularly chilling aspect of the James Webb Telescope's observations is the potential link between Proxima B's light emissions and its atmospheric anomalies. If these are indeed signs of industrial activity, then the planet's inhabitants might be grappling with environmental challenges not unlike those faced on Earth. Pollution, resource scarcity, and climate change could be universal problems for technologically advanced societies. This realization forces us to confront the possibility that our quest for intelligent life might reveal more about ourselves than we ever anticipated. Moreover, the discovery of artificial lights on Proxima B has implications beyond astronomy. It challenges our philosophical and ethical frameworks, compelling us to reconsider humanity's place in the cosmos. Are we ready to share the universe with another intelligent species? And if so, what responsibilities come with that knowledge? These questions demand careful consideration as we move closer to unlocking the questions of our galactic neighbors. The search for extraterrestrial intelligence has always been a double-edged sword. On one hand, it represents humanity's unyielding curiosity and desire to connect with the unknown. On the other, it forces us to confront the possibility of encountering civilizations far more advanced and potentially more dangerous than our own. The James Webb Telescope's discoveries on Proxima B exemplify this dichotomy. They inspire awe and wonder, but also caution and fear. As we continue to analyze the data from Proxima B, one thing becomes clear: the universe is not as empty or as benign as we once thought. The James Webb Telescope has opened a window into the unknown, revealing glimpses of a reality that is both fascinating and frightening. Whether Proxima B's lights are the product of intelligent life or some other phenomenon, they serve as a reminder of the vastness and complexity of the cosmos. And they challenge us to prepare for whatever truths may lie beyond our understanding. The path to uncover the questions of Proxima B is far from over. The James Webb Telescope's findings are just the beginning of what promises to be a transformative era in space exploration. As we venture further into the universe, the questions we face will only grow more profound. But with each discovery, we inch closer to understanding our place in the cosmos and to confronting the realities that await us among the stars. Each new finding about Proxima B adds to a bigger story that makes us wonder if we're ready for what's coming. Advanced technology in a harsh world. Despite the monumental achievements of humanity in space exploration, it is clear that we are still standing at the threshold of a vast and largely uncharted cosmos. The significance of Proxima B's revelations is magnified by its proximity, a mere 4 light-years away, which places it well within our interstellar neighborhood. Yet, even at this relatively short distance, the challenges of confirming the presence of intelligent life remain daunting. From technological hurdles to interpretative limitations, each discovery is as much a question as it is an answer. And while the James Webb Telescope has delivered unparalleled insights, it is up to humanity to piece together this cosmic question with diligence and an open mind. The ongoing search for life on Proxima B also underscores a broader truth about human nature. Our desire to explore, to understand, and to connect transcends generations and technologies. It is a testament to our unyielding spirit that we have built tools capable of probing the farthest reaches of space. Yet, the revelations from Proxima B also serve as a cautionary tale. The potential existence of an advanced civilization just 4 light-years away forces us to consider the consequences of our actions on Earth and in the universe at large. Whether through pollution, resource depletion, or conflict, the challenges we face on our own planet may well be mirrored on Proxima B. It is this duality, the promise of discovery and the specter of caution, that defines our relationship with the cosmos. The James Webb Telescope, with its extraordinary capabilities, has become a symbol of this duality. Its discoveries inspire awe and wonder, yet they also remind us of the limits of our understanding. As we look to the stars, we must also look inward, grappling with the ethical, philosophical, and practical questions that arise from our exploration of the universe. The story of Proxima B is not just about what lies beyond our solar system, it is also about what lies within ourselves. As humanity stands on the cusp of a new era in space exploration, the importance of collaboration and shared knowledge cannot be overstated. The search for life on Proxima B, like all great scientific endeavors, is a collective effort. It requires the expertise of astronomers, the imagination of theorists, and the support of societies around the world. Together, we are building a bridge to the stars, one discovery at a time, and with each step, we are reminded of the boundless potential of human ingenuity and the profound answers that await us in the cosmos. The James Webb Telescope's observations of Proxima B mark a pivotal moment in our exploration of the universe. They challenge us to expand our horizons, to question our assumptions, and to embrace the unknown. But they also compel us to act with caution and foresight, recognizing the immense responsibility that comes with our expanding knowledge. Whether Proxima B holds the key to understanding our place in the universe, or simply serves as a mirror reflecting our own struggles, its significance cannot be overstated. The path to uncover its questions is far from over, and the lessons it offers are only beginning to unfold. As we continue to gaze at the stars, we are reminded that the universe is both a frontier and a reflection. It is a place of endless possibilities, where every discovery opens the door to new questions and new horizons. And while the path to Proxima B may be fraught with uncertainty, it is a path worth taking. For in the search for life beyond our world, we may ultimately find ourselves. The James Webb Telescope has shown us the way forward. Now it is up to humanity to follow its lead, embracing the unknown with courage, curiosity, and a profound sense of wonder. The universe isn't just full of stars and galaxies. It's a place with big questions we still don't understand. What came before the first explosion? The universe is unbelievably vast, filled with questions that stretch far beyond what most of us can imagine. Among these, one question stands out. Where did it all begin? Scientists talk about the Big Bang Theory, which suggests everything started from an incredibly hot and dense point that suddenly expanded. But even with all the research, no one really knows what triggered this massive explosion. Was there something before the Big Bang, or did time itself start ticking at that moment? Questions like these keep scientists awake at night because they strike at the very core of existence. Then there's the big question about the end of the universe. Observations tell us that the universe is expanding, but it's not just growing, it's speeding up. This is because of something called dark energy, which makes up a whopping 70% of the universe. We've labeled it, but we don't know what it is. Will this strange force push the universe into a never-ending expansion, leaving it cold and lifeless? Or could it all reverse, pulling everything back into a colossal crunch? Scientists can't say for sure, and that's a chilling thought. When you look at what the universe is made of, things get even weirder. The stuff we see, stars, planets, galaxies, is just 5% of everything out there. The rest, 25%, is dark matter, which doesn't interact with light and is completely invisible. The remaining 70% is that dark energy again. What's dark matter made of, and how does it work? Figuring this out could rewrite everything we know about physics and astronomy. Another head-scratcher is the imbalance between matter and antimatter. When the Big Bang happened, there should have been equal amounts of both, and they would have destroyed each other. Yet here we are, in a universe filled with matter. Why didn't antimatter wipe us all out? This imbalance is one of the universe's greatest unsolved riddles. Black holes add another layer of intrigue. These regions of space have gravity so strong that nothing, not even light, can escape. At the heart of a black hole lies a singularity, where physics as we know it completely breaks down. And then there's the information paradox. If something falls into a black hole, is all the information about it gone forever? This question has stumped scientists for decades, challenging our understanding of how the universe works. Parallel universes sound like science fiction, but they're serious scientific speculation. Some theories suggest our universe might just be one of countless others, each with its own rules and constants. If that's true, where are these other universes, and how do we prove they exist? Right now, it's all theory, but the implications are mind-blowing. The nature of time itself is another unsolved problem. We experience time moving forward, but physics doesn't actually demand this. So why does time feel like it has a direction? Is it because of entropy, the idea that everything naturally moves from order to disorder? Cracking this problem could change how we think about reality. Life on Earth feels unique, but is it? Scientists believe life began billions of years ago, but no one knows exactly how it started. Did some chemical reactions in a warm little pond kick things off? And if life could arise here, why not on one of the countless planets in the universe? With so many stars and even more planets, it feels like the odds are good. But we still have no proof of life beyond Earth. Quantum mechanics, the study of the tiniest particles, is equally baffling. Particles can exist in multiple states at once until we observe them. How does merely looking at something make it choose a state? And what does that say about the nature of reality? These are questions that sit at the intersection of physics and philosophy. Scientists also dream of unifying the fundamental forces of nature. Right now, we've got the Standard Model, which explains three forces: electromagnetic, weak nuclear, and strong nuclear. But gravity, the fourth force, doesn't fit neatly into this framework. A theory of everything, one that ties all four forces together, is the holy grail of physics. But it's been maddeningly elusive. Cosmic inflation, the idea that the universe expanded incredibly fast just after the Big Bang, is widely accepted. But what drove this rapid inflation? Scientists suspect a particle or field, often called the inflaton, but no one knows for sure. Solving this would help explain how the universe grew into what we see today. The way galaxies are arranged in the universe also raises questions. They form clusters and superclusters, separated by enormous voids. What caused this large-scale structure to form? And what role did dark matter and dark energy play in shaping it? These are questions that keep astronomers busy. Cosmic rays are another strange thing. These high-energy particles hit Earth's atmosphere. But where do they come from? Some originate from the sun, but others travel across vast cosmic distances. What powers them, and why do they move so fast? Answering these questions could shed light on some of the universe's most violent phenomena. Neutrinos, tiny particles that barely interact with anything, are another unsolved piece of the problem. They come in three flavors and can switch between them, a process called oscillation, but we don't know their exact masses or why they behave this way. Understanding neutrinos could open up entirely new areas of physics. Some theories propose extra dimensions beyond the familiar three of space and one of time. These extra dimensions could explain things like gravity's weakness compared to other forces, but proving they exist is a monumental challenge. If they do, it would fundamentally change our understanding of the universe. Why do physical constants have the values they do? For example, why is the speed of light the speed it is? If these constants were even slightly different, the universe might not support life. Are these values random, or is there a deeper reason? It's a question that cuts to the heart of why the universe is the way it is. Exoplanets, planets orbiting stars outside our solar system, have exploded our understanding of planetary diversity. Some lie in their star's habitable zone, where liquid water might exist. Could any of these worlds host life? Finding out is one of the main goals of modern astronomy. Fast radio bursts are another recent discovery. These intense, short bursts of radio waves come from distant galaxies, but their origin is a problem. Are they caused by natural phenomena or something more exotic? Scientists are racing to figure it out. The first stars and galaxies hold clues to how the universe evolved. These early structures were the building blocks for everything that followed. Studying them helps us understand how we got from a hot, dense early universe to the vast, complex cosmos we see today. Gravitational waves, ripples in space-time caused by massive accelerating objects, have opened a new way to observe the universe. They let us study things like merging black holes and neutron stars. But what else can they reveal about the cosmos? The possibilities are endless. Cosmic voids, vast regions with few galaxies, are another area of interest. Why are these spaces so empty? And what do they tell us about the universe's structure? Studying them could provide new insights into dark matter and dark energy. The universe is filled with questions, each more fascinating than the last. From the origin of everything to the tiniest particles, there's so much we don't know. And that's what makes it all so exciting. The quest for answers continues, and each discovery brings us closer to understanding this incredible cosmos we call home. Could Proxima B be a warning of what lies ahead for Earth, or is this just fear-driven speculation from scientists? Share your thoughts and don't forget to like and subscribe for more.